All right, so in part one, we left off with finding our new x and y in terms of x prime, y prime, x prime, y prime that we're going to substitute in for our equations, there for our x's, and then here for our y's. Notice when we substitute those in, we have all these kind of nasty things, and this is where we have to be really attentive to our details. So if we're squaring something, notice we're going to double distribute. So we got to multiply two things by both sides. Okay, so then I have an xy, so I put my x and I put my y in there, just leaving my coefficient of square root of 3 out in front, and then I have my y terms. Okay. So I'm going to be very careful here to recognize that this is a skill in itself. So what I strongly encourage you guys to do is pause the video here and go ahead and distribute this out. Okay, and notice that I couldn't have room on the smartboard to do this because it takes a lot of space to do it. I used a whole sheet of paper to multiply this through. So go ahead and pause the video and see if you can multiply this through. So after I multiplied all these through, I go ahead and just kind of group. That was the first one. That was the first one with a factor of square root of 3, and this one was the second one. So after I multiplied those through, I went ahead and I distributed my 2 and my square root of 3 to all my terms, and I got those equations. Okay, so go ahead and pause the video and make sure you get the same thing when you distribute those through. Next, what we got to do is we got to group like terms together. So I went ahead and said, all right, remember, my goal is to really get rid of all my x and y terms because we don't know how to complete squares and deal with conics with x and y terms. So I first looked at my xy term here, my xy term here, my xy term here, my xy term here, and my xy term here. When I grouped all those together, I got a negative 2/3 fourths minus 2/3 fourths plus 3 square roots of 3 and minus square root of 3 over 4 plus 2 square roots of 3 over 4. Notice we get 0 after we collect all our like terms. At this point, then we know we've done it correctly for the most part because we know we got a 0. We don't have this xy term anymore, which is great. So then what we're able to do is group our other terms together. So I'm going to get my x terms. Okay. And what do I get? I get 6/4 plus 3/4 plus 3/4 plus 1/4 is 10/4. And then I simplify that and I see that I have 5 over 2 x squared. The last thing I want to do is group my y terms. So there's one y term, there's my other y term, and this y term. And I get 2/4 minus 3/4 plus 3/4, which is going to be 2/4. And 2/4 is the same thing as 1/2, and that is the y prime term that I have. So notice I have 5 over 2 x prime squared, 1 over 2 x prime squared, and that's going to be a lot easier working with my parabolas. So I finish off right here, okay, and we just move this 10 over to the other side here, and now what I want to do is I want to make sure I get this equal to 1, so I divide both sides by 10, and what I get is there's my conic. And that looks, other than the primes, this looks exactly like what we've done before. We have a term, we have a b term, these are squared. So then from there we know that b squared is equal to 4, so that implies b is equal to 2. I know that a squared is equal to 20, so that implies that a is equal to the square root of 20, or 2 square roots of 5. So when we're asked to graph this now, we can go ahead and rotate my axis 30 degrees right here. And now I have my new axes, x prime, y primed. And I'm going to graph my ellipse here. Notice the y has the a value, so that means it's going to be stretched in the y direction. And then from that I went up this distance here to be 2 square roots of 5, and I can go down here and have this distance here be negative 2 square roots of 5, and then my b value, so this was my a value there, and then my b value was 2, 2. Notice that these points that are labeled here are in reference to our x prime, y prime. But now we have the tools to be able to graph these ellipses that are rotated axis. Make sure you guys walk through and practice that double distribution, and I'll see you in class tomorrow.